Hello everyone, we are JAMG team, and today we are presenting our results for the 2023 SPE Datathon, Zeroing Methane Emissions. Methane is a powerful climate pollutant that is emitted intentionally or unintentionally during oil and gas production and processing, power generation, waste management, and other human activities. It can be estimated that methane is approximately 28 times more harmful than carbon dioxide to climate change. And so, methane measurement and mitigation has received significant attention in recent years due to its large impact in climate change in both the short term and long term. And so, mitigating these emissions in reaching worldwide net zero targets are very important. In this challenge, we were given two sets of satellite imagery from the Global Airborne Observatory and NASA's Next-Gen Airborne Visible RF Spectrum. The objective was to identify methane plumes from the images and determine the emission sources based on a series of attributes set. On our journey, we started by taking a look at the Permian Basin and other sources from the US, and this resulted in about 6,000 images collected containing plume data. We then cleaned and augmented this data by layering sector information for feature engineering. This was then passed through our ML model, which classified the emissions, and we used a UNet model to quantify bottom-up estimations. With that, we can consolidate the top-down and bottom-up and create a marginal abatement cost analysis, or a MAC chart. To gain insight from this data, we needed to quantify it. And once emissions were quantified and source types identified, a closer look at the emissions could be made. Looking at this, we decided that there are different sectors. There is the animal, coal, oil, and natural gas, power plants, and waste sectors. Looking at this data allowed us to identify where the significant information is located. For example, oil and natural gas sector has high variability, and there are many facilities to look at, as well as other typical facilities like waste, where there's only a couple, but mitigation options are out there. These significant agents were identified on the map, here in the Permian side and on the waste side. Further analysis of the data showed us that there are super-emitters. A small number of sources contribute to the majority of the emissions. A significant portion of these sources are in the oil and gas database. In order to mitigate these emissions, top-down and bottom-up must be reconciled. Opportunities are there. If the reported vented gas in the Permian dataset is recovered instead of being flared, about $400 million per year of extra revenue can be acquired, assuming a natural gas price of $2 per million BTU. However, there are challenges with this. Satellite survey consistently find higher emissions than the reported, and reconciling top-down and bottom-up is crucial for understanding the actual volumes of sources. Mitigation solutions are implemented in the ground. Therefore, an accurate bottom-up model is essential, and so we need to create this for mitigating emissions. Looking at a typical bottom-up, we can take Alberta for example, as we expect this distribution of emissions to be representative in other countries as well, with a large chunk of it being pneumatics, tank venting, fugitive, and other emissions. For these emission sources, there are mitigation solutions available. For pneumatics, for example, there are high bleed to low bleed conversions as well as compressed air installations. These emissions all have mitigation technologies that can be applied. So let's take a look at a good example from our dataset. In this one, the top-down estimates about 100 kilograms per hour of methane emission, where our bottom-up estimation done through engineering knowledge of equipment and emission sources estimated about 60 kilograms per hour. Why are these so close? Well, there's a good inventory of the equipment as well as up-to-date process information on this facility. And so exactly what kind of emissions are being created in this facility can be calculated. And for this, we can create a roadmap of how these emissions can be mitigated. Here, I'm showing that marginal abatement cost curve, or the MAC chart. And essentially, we can tell exactly how much we can mitigate and what it's going to cost you. This can be friendly for different vendors and operators as they can see exactly what their specific equipment are needed and what needs to be done for their emissions specifically. You can do a similar type of analysis for different sectors. Here we have a landfill with a top-down estimate of about 4,000 kilograms per hour. For the bottom-up, different types of information is needed, like the area, the type of the facility, the waste, and facility-specific information, like dry sewage, slug, and dirt using to cover this waste. When we do a bottom-up estimation, we use IPCC methods, and they use an average value. But as you can see, our estimated values are about 10 times lower than the aerial survey. This could be attributed to the fact that perhaps estimations and averages are not useful for different facilities, as you can see for this one. Considering that we were 10 times off, steps need to be taken in order to reconcile the two. And this involves engaging the stakeholders, operators, and regulators, gathering that information so that it can be analyzed for the facility. Only then can mitigation options be assessed, implemented, and monitored. For example, we thought that geomembranes might be a good alternative to the dry sludge that they were using in their current site, but that can only be truly assessed once you have reconciled the bottom-up and top-down estimations. There are a couple of learnings that we can take from this study. One of them is that reconciling the satellite imagery and bottom-up estimation is critical for mitigation efforts. Understanding the source and rate leads to a reliable roadmap for these emissions mitigations. Engagement is essential. We are measuring and identifying the sources, but we need to engage and have site-specific data so that we can assess mitigation options, implement them, and monitor them, so that we can have a cleaner future. Thank you for listening to our presentation.